Hello students, the content of the video is about primary based and replicated protocol. I am Mrs. Kavita S. working as assistant professor at MIT Academy of Engineering. Consistency and replication. In distributed systems, data will be replicated. The reasons for the replication are basically improved performance and improved reliability. Replication can lead to inconsistencies. So, how best the updates can be propagated so that these inconsistencies are not noticed without crippling the performance. For that, there are some protocols. First one is primary based protocol. The primary based protocol is a class of consistency protocols used in distributed systems to maintain consistency across replicated data. In this protocol, one replica of the data is designated as the primary or the leader, and all updates must be directed to this primary replica. The primary is responsible for ensuring that changes are propagated to other replicas, which are known as backup or secondary replicas. The main idea behind the primary based protocol is that by having a single authoritative source for updates, it becomes easier to maintain consistency across all replicas as it avoids the need for complex conflict resolution mechanisms that arise in multi-master systems. Primary based protocols. Here, each data item is associated with a primary replica. The primary is responsible for coordinating writes to the data item. There are two types of primary based protocol. First one, remote write, and second one is local write. Remote write protocols. With this protocol, all writes are performed at a single remote server. The model is typically associated with traditional client-server systems, which is shown in the diagram. Then primary backup protocol, a variation. Here, writes are centralized, but the reads are now distributed. The primary coordinates with the writes to each of the backups. The bad and good of primary protocol. That is, bad is performance. All of those writes can take a long time, especially when a blocking write protocol is used. Using a non-blocking write protocol to handle the updates can lead to fault-tolerant problems. Good thing is that the benefit of this scheme is, as the primary is in control, all writes can be sent to each backup replica in the same order, making it easy to implement sequential consistency. Local write protocols. In this protocol, a single copy of the data item is still maintained. Upon a write, the data item gets transferred to the replica that is writing. That is the status of the status of primary for a data item is transferable. This is also called fully migrating approach. Then local write example. Local write protocols example. So here, primary based local write protocol in which a single copy is migrated between the processes are shown. That is, initially the client will give a read or write request, then forward the request to the current server for X, and third step will be moving the item to the client server, and fourth step will be return the result of operation on the client server. Then local write issues. The big question to be answered by any process about to read from or write to the data item is, where is the data item right now? It is possible to use some of the dynamic naming technologies studied earlier in this course, but scaling quickly becomes an issue. Processes can spend more time actually locating a data item than using it. Then local write protocols, a variation. Here, primary backup protocol is shown in which the primary migrates to the processes wanting to perform an update, then updates the backup. Consequently, reads are much more efficient. Stepwise actions are shown in this diagram. Replicated write protocols. With these protocols, writes can be carried out at any replica. Another name might be distributed write protocols. There are two types, active replication and majority voting quorums. Active replication. A special process carries out the update operations at each replica. Lamport's timestamp can be used to achieve total ordering, but this does not scale well within distributed systems. An alternative variation is to use a sequencer, which is a process that assigns a unique ID number to each update, which is then propagated to all replicas. This can lead to another problem, that is replicated invocations. Active replication. The problem of replicated invocation, that is B is replicated object, which itself calls C. When A calls B, how do we ensure C is not invoked 3 times? That is, the problem is redundant invocation. Now the solutions for active replications. First solution is using a coordinator. Using a coordinator for B, which is responsible for forwarding an invocation request from the replicated object to the C. And second solution is returning the results from C using the same idea. That is, a coordinator is responsible for returning the result to all B's. Note the single result returned to A. Next protocol is quorum based protocol. Client must request and acquire permissions from the multiple replicas before either reading or writing a replicated data item. Consider this example. A file is replicated within a distributed file system. To update a file, a process must get approval from a majority of the replicas to perform a write. The replicas need to agree to perform the write. After the update, the file has a new version number associated with it, and it is set at all the updated replicas. To read, a process contacts a majority of the replicas and asks for the version number of the files. If the version number is the same, then the file must be the most recent version, and then the read can proceed. Generalization of the quorum protocols. NR plus NW must be greater than N, and NW should be greater than N by 2, where N is the total number of replicas, that is total number of replicated nodes in the system where the data is replicated. NR is the number of replicas required to acknowledge a read operation. This ensures that the system reads from the enough replicas to guarantee that it gets the latest value. NW refers to the number of replicas required to acknowledge a write operation. This ensures that the write is propagated to a sufficient number of replicas. These are the references used for the contents of this video. Thank you.